Lesson 3.1. In this video, we're going to learn how to identify relationships between lines. It's a lot of definition. Most of them are probably fairly intuitive that you have covered in middle school. And there's one or two concepts that may be a little bit more challenging. So let's see. First one, parallel lines are two lines that lie in the same plane. In other words, they are coplanar, right? Coplanar. And they do not intersect. So we use this symbol to denote it. Those are parallel lines. So if I say line A and line B are parallel. Perpendicular lines are lines that intersect to form a right angle. So there's a 90 degrees involved in that, and we use that symbol to denote that. So if we look at the cube here, and if I take this line on top in the back here, this black line here, if I say that's my line A, and then if I go for this one in the front, I call this line B. Let me change the color. I'm sorry about that. Change it to, how about orange or green? See if this works. There we go. So this line and this line in the front, it would be parallel because these two edges will never meet each other, right? They go on and on and on and on forever, and they will never meet. And they're on the same plane. That's important. Parallel lines have to be coplanar. They have to be on the same plane. But notice that if I call this A and call this B, and then this line here, if I call this one line C, C and B would be perpendicular because there is a 90 degree in the corner there. So I can write A is parallel to B and B is perpendicular to C. Okay? Now, the hard part is skew lines. Skew lines, pay attention, skew lines are never in the same plane and they do not intersect. So if you look at A and C, AC are skew lines because C will just go on and on forever into the space on the plane in the front, and A will go sideways into space on the plane in the back. These two planes will never intersect with each other, and these two lines will never intersect with each other. So AC are skewed lines. And some people may say that in this cube, see if I use this one, if I call D, D and A are in two separate planes, and they don't intersect. No, they don't. However, if I cut this cube sideways like that, and I would form a, there we go, I would form a invisible, somewhat invisible, right here, dotted line, meaning you can't see those. So I would have a diagonal side, and in that plane, my line A and my line D are parallel, and they're coplanar in that plane. So no, line A and line D are actually, in fact, on the same plane. You can create a plane that includes both of them, okay? So the rest of it is pretty intuitive. Parallel planes do not intersect. Perpendicular plane has a line that intersects the plane with a 90 degree angle. So for example, this one, let me change the color again. This time I will use purple. This line, purple line, if we call this E, would be perpendicular to the plane, the surface at the bottom of the cube. Okay, so we'll see more exercise of it later. Determine whether the lines are parallel, perpendicular, or neither. So T and U. T is right here. U is this here. They intersect. They can be parallel. And at the intersection, this angle here does not tell me that it's a right angle or not, so they're not perpendicular. So T and U is neither. Okay, now let's look at S and T. S is the vertical line, so let me graph that. No, I'm sorry, S is this line. T is this line. Ah, there we go. And notice that the most important are these two arrows, one on each one, and that means they're parallel to each other. And that's how we label them in diagrams for parallel lines with little arrows on the lines. And so that's S and T. The third one is R and U. R is here, U is here. They intersect, and at the intersection, there's a right angle. So R and U are perpendicular to each other. Here's some exercises. Give it a try yourself, and I'll check in with you. Example 2 is to identify skew lines. Determine whether the lines are skew. L and M. If you see L and M is on that plane, the shaded plane, and L punches through that. If you think about the plane as a piece of paper, L punches through it, and it intersects M at that point. So they're not, because they're intersecting each other, they are not skew. L and N, on the other hand, they each belong to two separate planes, and they don't intersect. So yes, L and N is skew lines. Okay, M and N, they're coplanar, they're on the same plane, therefore they're not. So not skew. The first one is also not skew lines. So skew lines is whether the lines are on the same plane. And here's an exercise. I'm going to leave this one to you as well. Last example, identify relationship in space. Here we have three planes, R plane, plane R, plane P, and plane Q. So name a plane that appears to parallel to plane P. And if it's parallel, I would say, especially when it says appears, and it looks like plane P is parallel to plane Q. Okay, there's no precise information that tells us, but from the diagram, that's our observation. So that's A. For B, name a line that's perpendicular to R. There are several lines here. I see L, I see N, and I see M, and it looks like M. Whenever I think about a line perpendicular to a plane, I think about a water bottle or a glass of Coca-Cola, a bottle of Coca-Cola sitting on the table. And if my Coca-Cola is my line, then the Coca-Cola is perpendicular to my tabletop. So in this case, I would say it's line M is perpendicular to plane R. And last one, name a line that's skew to line M. So whichever line is, it can be on the same plane. So that gets rid of the possibility of L. And then on N, on plane Q, I've got line N. So N and M are on two separate planes, and they will never intersect with each other. And so they are skewed lines. Okay, that's it for this packet, and I will see you in class. Bye, guys.